In this lecture, we will talk about solving linear equations. First, an equation is something with an equal sign in it somewhere, hence the name equation. The algebraic expression 4x plus 5 is not an equation because there's no equal sign. If rather we had 4x plus 5 equals 7, this is an equation, because now we have an equal sign. Recall from last lecture, a linear polynomial is a polynomial with a variable that has a highest power of 1. So if our variable is x, then the highest power of x that we see in our equation is 1, or just x to the first, or simply x. A linear equation is a polynomial equation that is linear. For example, 4x plus 5 equals 14 is a linear equation, because the highest power of x is 1. The equation 12x plus 2 equals 5x plus 4 is also linear, because the highest power of x is 1. The equation 5 times x plus 1 equals 1 is linear also, because when we open the parentheses, we get 5x plus 5 equals 1, which is a linear equation. However, the equation x squared plus 1 equals 5 is not linear, because the highest power of x is now 2 rather than 1. The equation x squared plus 1 equals 0 is also not linear, as the highest power of x is now 2. Same with x to the third power plus 1 equals 0, which is also not a linear equation. The equation x times x plus 1 equals 1 is also not linear. It may look linear, since each factor of x and x plus 1 on the left side are linear, but when we multiply them using the distributive property, we get x squared plus x equals 1, which is no longer a linear equation. Whenever we have any equation, not just linear, to solve the equation means to find what the variable is equal to. For example, suppose we have the simple equation x plus 3 equals 5. To solve this equation means to find what x has to be equal to, so that when we substitute that value for x, we make the equation true. Clearly, x equals 2 is the solution. Or consider the equation x to the second power equals 1. To solve this equation means to find the value, or values in this case, that x has to be equal to make the equation true. It's clear that x equals 1 is one solution, but we need to be careful since there are other solutions. For instance, x equals negative 1. They both satisfy the equation x squared equals 1 when we substitute in for x. Equations may have one solution, no solutions, or many solutions. It all depends on the nature of the equation. The simplest type of equation is a linear equation, so those will be the first ones that we will learn to solve. One of the fundamental tricks to solving equations is that we can perform the same operation on each side of the equation without changing the equation. Let's illustrate what we're saying by returning back to our balance scale analogy. Suppose we want to solve the equation 5x plus 3 equals 13. Find what x has to equal. Let's interpret the equation in terms of balance scales. Let x be the weight of one pair in terms of stones. The 5x in the equation is saying that we have the weight of 5 pairs. The left side is 5x plus 3. Therefore, that means that on the left side of the balance scale, we have 5 pairs and 3 stones. On the right side of the balance scale, we have 13 stones. How can we determine what one pair weighs? If we subtract 3 stones on each side of the scale, we do not change the balance, and so taking away 3 stones on both sides makes us have 5 pairs and 10 stones. That means that 5 pairs weigh 10 stones. That is, in algebraic terms, 5x equals 10. Now, if 5 pairs weighs 10 stones, it must mean that each pair weighs 2 stones by dividing 10 by 5. The way we solve this equation algebraically is by performing the same operation on each side of the equation. If 5x plus 3 equals 13, we can subtract 3 on both sides to obtain 5x plus 3 minus 3 equals 13 minus 3, which simplifies to 5x equals 10. Now we divide both sides by 5 to get 5x divided by 5 equals 10 divided by 5. On the left, each 5 cancels, and we're left with x equals 2. Another example. Solve 4x plus 5 equals 17. we subtract 5 on each side of the equation to get 4x plus 5 minus 5 equals 17 minus 5. So that's 4x equals 12. Now divide both sides by 4 to get 4x divided by 4 equals 12 divided by 4. So that equals x equals 3. Another example. Solve 3x minus 5 equals 10. This time we add 5 to both sides. The reason being that we want to isolate the left side with only the x by itself. And if we'd rather subtract 5 from both sides, we'd be left with 3x minus 10 on the left side, which is not good. It doesn't simplify the equation. So we add 5 to both sides of the equation to obtain 3x minus 5 plus 5 equals 10 plus 5, or 3x equals 15. Now we divide both sides by 3 to get 3x divided by 3 equals 15 divided by 3, and that is x equals 5. Another example. Solve 2x plus 1 equals 4. Here we subtract 1 from both sides, so 2x plus 1 minus 1 equals 4 minus 1. So that's 2x equals 3. Now divide both sides by 2 to get 2x divided by 2 equals 3 divided by 2, or x equals 3 divided by 2. Note that in this equation, the solution is not an integer anymore. Solutions to linear equations do not need to be integers. Another example. Solve negative 2x plus 1 equals 3. Subtract 1 from both sides, so negative 2x plus 1 minus 1 equals 3 minus 1. To get negative 2x equals 2. Now divide by negative 2 to isolate the x. And so negative 2x divided by negative 2 equals 2 divided by negative 2, which simplifies to x equals negative 1. Remember that when dividing numbers, the sign is just like multiplying them. As a negative times a positive is a negative, same thing is true that dividing a positive by a negative is a negative as well. Another example. Solve 4x plus 3 equals 2x plus 9. Here we've got variables on both sides, but the idea is to get the x by itself on one side. To do that, first we can subtract 2x from both sides. So 4x plus 3 minus 2x equals 2x plus 9 minus 2x. This wipes out or cancels the x term from the right side of the equation and simplifies to 2x plus 3 equals 9. Now we know how to solve 2x plus 3 equals 9. Subtract 3 from both sides, or 2x plus 3 minus 3, equals 9 minus 3, so 2x equals 6. Divide both sides by 2, for 2x divided by 2 equals 6 divided by 2, and that yields x equals 3. Another example. Let's solve 5 times x plus 3, in parentheses, plus 13, equals 2 times 4 minus x, in parentheses, plus 6. So here, first we've got to open up the parentheses. And we can do that with the distributive property and get 5 times x plus 3 into 5x plus 15, and get the 2 times 4 minus x as 8 minus 2x. Overall, that gives us 5x plus 15 plus 13 equals 8 minus 2x plus 6. Simplify by combining the like terms, and we've got 5x plus 28 on the left side, and 14 minus 2x on the right. To isolate the x on one side, add 2x to both sides to cancel it from the right. And what we end up with is 5x plus 28 plus 2x equals 14 minus 2x plus 2x. So that equals 7x plus 28 equals 14. This is a type of equation we already know how to solve. Subtract 28 from both sides to obtain 7x plus 28 minus 28 equals 14 minus 28, and we get 7x equals negative 14. Isolate the x by dividing both sides by 7. 7x divided by 7 equals negative 14 divided by 7, and that simplifies to x equals negative 2. Let's try a more complex example. Solve 2/5 x minus 1/3 equals 5 divided by 6. The idea is the same, but we use fractions. add 1/3 to both sides to get 2x 2/5 x equals 5x plus 1/3, which simplifies to 2/5 x equals 7/6. Now multiply both sides by the reciprocal 5/2 to get 5/2 times 2/5 equals 5/2 times 7/6. That will wipe out the right side coefficient to isolate the x. The fraction on the left side simplifies to a 1, or an x, and on the right side, 5/2 times 7/6 equals 35/12. So the answer turns out to be x equals 35 divided by 12. We can leave it as a fraction or simplify it to a decimal by dividing. We can always check to see if the answer we get is correct by substituting it into the original equation. A lot of problems in the world can be solved by setting up a linear equation. Solving a linear equation is much easier than setting one up. Here are some word problems, puzzles in a way, where we solve them by setting up an equation. Let's take some examples. We'll start with this one. Suppose that a container contains dimes and quarters. There are 10 more dimes than quarters, and the total amount of money is $3.10. Find out how many dimes and quarters are in the container. Of course, we can try solving this puzzle by brute force, just by guessing possible numbers and see if they work, but let's try something more creative and solve it algebraically. We let x be the number of quarters in the container. We're using the letter x because it's a variable. It's a quantity that we don't know the value of. By wording the problem, there are x plus 10 dimes, since we were told originally that there are 10 more dimes than there were quarters. Each quarter is 25 cents, and if there are x quarters, that means there's 25x cents worth of quarters, since each quarter is 25 cents. Each dime is 10 cents, and if there are x plus 10 dimes, it means there are 10 times x plus 10 dimes, since the total value of the dimes will be 10 times whatever the number of dimes there are. In total, we have 25x plus 10 times x plus 10 cents. The 25x being 25 cents times the number of quarters, and the 10 times x plus 10 being 10 times the number of dimes there are in cents. Note that by varying the value of x, the variable, we get the total amount of money that we have. The problem says that we need to find out what x will be, or the number of quarters, and that the total amount of money will be $3.10. Since we're using cents, that's the same thing as saying 310 cents. Thus, the equation we can set up is 25x plus 10 times x plus 10 equals 310. We can then solve the equation by opening up the parentheses, 10 times x plus 10, into 10x plus 100. So we end up with 25x plus 10x plus 100 equals 310. Combining the like terms, we get 35x plus 100 equals 310. Subtract 100 from each side, and we've got 35x equals 210. Then we can isolate the x by dividing each side by 35, and we get x equals 6. So there are 6 quarters, because that's the way we originally defined x. Now, if we want to figure out how many dimes there are, we're told that there are 10 more dimes than quarters. So there are 6 quarters and 16 dimes. Let's look at another example. 3 consecutive integers add up to 93. Find out what they are. So here we say, let x equal the first integer. The next integer is the one right above it, so we can call it x plus 1. The one after that is 2 above the first one, so we can call that x plus 2. We're told they add up to 93. Therefore, x, the first integer, plus x plus 1, the second integer, plus x plus 2, the third integer, equals 93. So we've got x plus 1 plus x plus 2 equals 93, and adding like terms, that simplifies to 3x plus 3 equals 93. We can solve this equation for x by subtracting 3 from each side, and we've got 3x equals 90. Divide each side by 3, and we get x equals 30. So that means our first integer is 30, our second integer is 31, and our third integer is 32. Checking them, we can add them all together and see that in fact they add up to 93. Linear equations can also be used to solve quadratic equations. Linear equations have the highest power of 1 on the variable. Quadratic equations have the highest power of 2 on the variable. For example, x squared plus x plus 1 is a quadratic equation. So is x squared equals 2x plus 1. To solve a quadratic equation, we move all terms to one side and factor. Then we use the fact that if a product of two numbers is equal to 0, that one of those two numbers must be 0. Let's look at a couple of examples. Solve x squared minus 5x plus 6 equals 0. Using the skills that we discussed in Lecture 3, we can factor x squared minus 5x plus 6 into x minus 2 times x minus 3. So we get x minus 2 times x minus 3 equals 0. Now each factor is set to 0. Either x minus 2 equals 0 or x minus 3 equals 0. In fact, they're both correct. We solve these linear equations as x minus 2 equals 0, meaning x equals 2, and x minus 3 equals 0, meaning x equals 3. Therefore, the solutions are x equals 2 and x equals 3. Both are correct. Second example. Solve x squared equals x plus 2. We subtract x and 2 from both sides to get a 0 on the right side. So we get x squared minus x minus 2 equals x plus 2 minus x minus 2. In essence, we get x squared minus x minus 2 equals 0. The reason for doing that is we want to bring all terms to one side and a 0 to the other. Thus, when we factor, we get x minus 2 times x plus 1 equals 0. Therefore, x minus 2 equals 0, and x plus 1 equals 0, from where we get that x can be 2 or x can be negative 1. Both are correct, and both work if you plug it back into the original equation. Another example. Solve 2x squared plus 5x plus 2 equals 0. Last lecture, we looked at this example and determined that to factor them, you can factor them into 2x plus 1 and x plus 2. Therefore, 2x plus 1 times x plus 2 equals 0. Therefore, one of the factors needs to be 0, so either 2x plus 1 equals 0 or x plus 2 equals 0. So we can solve x as x equals negative 1/2, that's from 2x plus 1 equals 0, or x equals negative 2, that's from x plus 2 equals 0. In these examples, we were able to factor these quadratic equations into linear factors and then set each one equal to 0. Sometimes it's hard to find the factor. We may wonder if there's an alternative method for solving these quadratic equations. That's the next lecture. In the next lecture, we'll discuss a formula for solving quadratic equations in general without the need to factor the quadratic.